Hi there, this is Dot Products Examples, and what I'm going to be talking about here is just a few examples on when and how to use dot products. And what we're going to look at first is this. I'm just going to tell you what it is because you might not know yet, but it's a drawbridge for, I don't know, castle or something. But basically, I'm just going to show you how you can kind of dissect this problem. So. First of all, we need to find our axes of rotation, right? Well, axes of rotation will be right here, right at the bottom of the opening and the bottom of the bridge. So, I mean, right here is where you'll see your axes. So, let me just find out. This is what we're going to put in as A. Well, we could put negative, but I just understand that the axis of rotation is going to be along the z-axis. So, rather than being worried about directionality, I'm just going to say that it's k. However, technically it is negative k from this point, from the point of origin. But I'm just going to say it's k, because I want to know, just from my perspective, what direction is it going to rotate. Okay, so arm. What is the arm? Well, let's only consider one chain, because I don't want, if we start considering two chains, then you got to do twice the amount of work, and since it's symmetric, you can just do one and then multiply the result times 2. So, we know that it's 20 feet away, so 20 feet, 20i. Just remember we're dealing with feet now. What about our force vector, our applied force? Well, I didn't write this down yet, but let's just say that the force in the chain is 300 pounds. Okay? Well, one thing we probably should pay attention to is that this can kind of turn into a triangle, right? 15, 20, what's this on the top? Well, if you did the Pythagorean theorem, and I'm just going to give you the result because this is a 3, 4, 5 triangle, but the Pythagorean theorem would come up with 25. So, knowing that, we could probably dissect what portion of the forces are which. So, which portion is x? Well, we know that it's going to be 300, but in the negative direction, right? So we just have to remember that, negative 300 times, essentially, cosine of this angle, which cosine is adjacent over hypotenuse, right? So that would be 20 over 25. Adjacent, right here, over hypotenuse. That's what cosine and sine are. So, let's just continue on. You have your I right there. Then we go plus 300, because it's going up, right? Then opposite over hypotenuse, k hat. And then you can work that on out. If you work that out, you'll get negative 240i plus 180j. So now that we have some of these like characteristics, we just essentially need to solve for it, right? We need to solve for what torque around that axis, and not just about the point of origin. So let's do it real quick. What's the moment of, I'm just going to say the axes, MA. Okay, so first of all, we got to put our axes coordinates in, our axes vector. So 0, 0, k. Okay, well, then we got to put our r in. It'd be 20, 0, 0. Then we got to put our f in. Negative 240, 180, 0. Great. Well, you'll find out that essentially if you just selected the top one, and you focus on each of these, the first two zeros, no matter what, the resultant is 0. So I'm just going to pay attention to this K, cross out all the ones that are adjacent to it, either in the same row or in the same column, and you get K hat times, essentially 20 times 180 minus 0. Now, one thing I do want you to notice is, notice how this 240 did not make a difference. And what that symbolizes, that 240 was essentially a force that's pushing into the wall. That is the portion that's actually pushing into the wall, pushing into the rotation. And whenever you're pushing onto the point of rotation, that's more of a binding rather than a rotating. So just realize that there is two components, but only one of them is taking effect. And that's the 180. That's the component that goes upwards. That's the Y component of the chain. So it's essentially f of y. This is going to equal our 180. That's what we solved for. Whereas the 240 is the f of x. Just food for thought. So anyway, as you solve for that, that's essentially going to equal 3600, right? That will equal 3600 k hat. Which, I mean, really, since we did the dot product, really there should not even be really a k hat in here, but the more appropriate term would be 1 right here. But I just like to put k and j and I in there just because it does give us a little bit of essentially directionality. So that's why I like to do it. So just remember your units. 3,600 foot-pounds, or pound-feet, whatever you want to call it, and that is only for one chain. So if we were talking about both chains, it would be 7,200 foot-pounds for both. And that just is a certain amount of almost awareness. You just can't be frazzled throughout the whole problem and then forget that you have to multiply it all by 2. So just make sure you don't forget something like that, because that's the kind of stuff that'll really kill you on a test.